So this is my project. Here this is a machine learning model. Here I have 6 models which are trained. So 3 for predicting the price and 3 for classification. Here I can enter like the area of my property, the bedrooms, number of bedrooms I have, bathroom, stories, parking space, and what is the furnishing status, whether it is semi-furnished, furnished, or unfurnished. And I can have some more features which I have in my property, and I can make it predict the price. So here 3 algorithms for prediction which I'm using. One is linear regression, random forest, and XGBoost. And based on the parameters like RMSE, it is telling us like linear regression is the best model over here. So apart from this, it is also predicting the price, and the confidence ratio is high for it. And the other models which are predicting the price is shown below. So here in the data analysis, you can see the various data items. Like here, it is like price distribution. So the price and how much count it is for the raw data, for the process data. Then this is your furnishing status distribution. How many are unfurnished, semi-furnished, and furnishing status. And this is the price for furnished, unfurnished, and semi-furnished. If we go to the model evaluation, we can see how these models have performed. So linear regression, basically, the correlation metrics for it, then the prediction versus actual value, the regression residual analysis. So here we can see the errors are probably the less. So this is for your XGBoost. This is only showing for algorithms which are performed, with models which are performed the best. So XGBoost, basically, we can see the classification out over here. And then we have this metrics for XGBoost classification, like your accuracy, precision, recall, and F1 score. Now here we also have model comparison, where we are comparing the various models. So like, for example, regression and random forest and linear regression, XGBoost. So what is the R2 score, R square score, right? And here the best model which is showing up, the higher the better. And we can see the linear regression has shown the best over here. Similarly, the RMSE comparison. So here we again have the best model. So the lower the better. So here again, your linear regression is performing better than the other models. So this is like XGBoost regression, random forest, linear regression, and tuned. So tuned are basically the algorithms. So we have the ability to tune our models by passing different hyperparameters. So these are based on the tuned hyperparameters, and even you see that even for the tuned, the linear regression is coming out to be low. Then MAE comparison. So again, lower the better. Again, linear regression is coming to the best. So for classification, we have other models like XGBoost was performing the best. So accuracy was highest for XGBoost. F1 score is also highest for XGBoost. And here we have one chart which shows the comparison between all these regression and classification models altogether. So if you look at the live comparison, here we have like linear regression is predicting this value to be 68 to 22, and this is your average prediction for the properties. Highest prediction is 68, and lowest prediction is 58, and the price range is 10 lakh from 58 to 68. So this is the live prediction comparison for the different models. And this is the feature value radar, which shows like basically the user has selected 1 bathroom and 3 bedrooms and area and all that. AC is there, and hot water is not there, basement, guest room, main road, parking is not there. So this is how it is showing us. Sorry, 4 bedrooms. So it is 1, 2, 3, 4, and 1 bathroom. So like this it is. So this is how. Then again, we can also predict the category. So if I click on predict category, it will show you the based on the classification. So it is showing XGBoost is the best model, and here it is classifying it as a high value property. So other algorithms are also predicting it, but the best model over here which has been trained is XGBoost classification. And here we can see the live comparison. So XGBoost is doing it a high, and here we have live prediction comparison, and again the feature value graph. Data analysis chart, model evaluation, model comparison remains the same for both predict and predict category and predict price. So if I change this to something like 16,000, and I'm selecting like 3-4 bathrooms, and here if I select predict the price, so here if I go to results, you can see the property value has increased to 1 crore 30 lakh. And this is again for the linear regression. And if I predict the property category, it is again XGBoost, which is a high value property over here. So if I choose the area to be like 1,000, bedrooms I'll choose 1, bathroom I'll choose 1, story I'll choose 1, and parking spaces I'll choose 1. And here furnishing status I'll choose like unfurnished. I'll remove all these things like which are there. Now I'll predict the price. So here you can see linear regression. It is now predicting the value to be 20 lakhs. And if I click on predict the category, it is now becoming a low value property. So this is my project is about. And here I have the code for it. So let me just walk you through the code. So here I have it starts with pipeline.py, basically, which is the main pipeline. And it has 3 main things. So first thing, it is calling your data processing.py, which will do data loading, cleaning, and feature engineering. So basically it will take, I'll explain each in detail. So basically loading the data and then cleaning it, finding all the null values and replacing them with the aggregate mean value. And then we have feature engineering, basically adding extra columns wherever required. So then we have also categorical encoding. We are categorical encoding. Basically, we are using one hot encoder to transform your category like semi-furnished, furnished, and unfurnished into the categories into 0 and 1 binary. And then we have EDA task over here. So it is exploratory data analysis. It will do the statistical analysis, correlation studies, and feature importance. It will. So these are the artifacts which are being generated by these. Like if we look over here, we have feature importance.csv. So it is telling us that the area is has the highest importance. So based on the area, the price prediction and all is based upon. So these are the 4 or 5 main things which are impacting the price: area, bathroom, parking, air conditioning, stories. Then we have missing count.csv, which is telling us does the data has any missing counts. Then we have summary statistics, which is telling us like what is the average count, and for each value what is the mean for each standard deviation, mean, minimum 25%, 50%, and all these are basically we have done the data normalization to show the value between 0 and 1. So that is why the data is coming like this. So here we have dtypes.csv, which is after this is all for the processed data. So then we have data cleaning summary. So none of the values were dropped and all that. So this is the consolidated bin feature. Basically, we have binned this into, so like area 0, 1, 2, 3, 4 and all this. If you look at the figures, this is about like it is for a univariate, it is showing us what is bivariate. So here it is bivariate between area and price, it is showing us. So this is bathroom and price. It is the correlation heat matrix, which matrix heat map, which is getting generated. So the furnishing distribution per count, furnishing status versus price, high value property price versus low value property price. And then the interaction area versus bathroom. And then we have this price category, high versus category versus price. So these all are being generated as part of these data processing and EDA. And then we have price distribution.png. So these are some of the graphs which have got generated. So then coming to the EDA part, EDA is basically, as we said, it is first it is taking up the data which has been cleaned by the data processing, and then it is performing some validations. It is doing univariate, bivariate, and multivariate analysis, and it is drawing some charts. And then it will generate the heat map for correlation and feature engineering sites, like encoding the feature relationships, one hot encoding, and all this. So if you go to pipeline.py, it is calling the data processing EDA, and it is also calling the modeling task. So modeling task is about training the machine learning models, and then hyperparameter tuning and performance evaluation. So the thing over here is like when we are calling this modeling task, it is by default the hyperparameter tuning is turned off, which should be on for your it can be turned on for your production. So it will automatically tune the models for the latest data, and it will choose the best model, and based on that it will do the prediction. If you want it like for the dev, you can turn off the hyperparameter tuning, and based on the best model which was generated. So here we have a model ML models, and you can see the comparison plots which it will create. So these were the same charts which we had shown up on the UI. So these are the charts which are getting generated by this model training after the model training. And here we have like for each model, it is showing us, one second. So like for the linear regression, it will show us the charts, like it is specific to like what is the linear regression, feature correlation matrix, what is the prediction, scatter plot, and the residuals. So similarly, it is generating the charts for every, so this is for linear regression, this is for logistic regression. So then we have random forest classification, which is showing like based on the random forest, what is the values. Similarly, this is for random forest regression. Then again, we have for XGBoost classification. So in this, we have taken up like 6 models, and we are training them, and we are doing the hyperparameter tuning for them, and then predicting based on the best model. So here I can show you the code for the model training. So here we have model training. In this, we are training the model. We have like 70% of the data which is used for training, and 30% which is used for validation, which is used for testing out. So here we are creating an experiment in an MLFLOW. So this is integrated with MLFLOW and Prefect. And here if you see like I can show you through the Prefect cloud and MLFLOW. So this is about my MLFLOW. So here we can see the housing ML experiments evaluation. This is all running locally. So this is my MLFLOW sheet. It shows like evaluated models were 7, promoted models were 4, and training models were 6. We come down, if you click on any like promoted models, it can show us the model metrics and all. If you go to the artifacts, it can show us it is logging all the comparison plots and the pipeline result over here, like housing ML experiment and for all the regression, and it is also showing like the other statistics, enhanced metrics for each of them. So these graphs are also getting set over here. If we go back to the experiments, here is my housing ML experiment. So here I can see the evaluation phase. So it is like a metric for all of these, like all the models. I can see the accuracy and RMSE for classification and regression and other things. So I can click on model metrics. If I go back, I can also see the metrics per model. Plus, I have also done system monitoring over here. So in the system monitoring, it is also logging the CPU usage. Here I've used PSUtil for it. So it is also logging the system CPU usage, memory, and other things over here. Meanwhile, while it loads, I can show you the Prefect cloud. So this is the flow which got generated for it. And these are the executions which were done for it. So if you look at this particular, it is the complete flow which shows up. So it is first calling the data processing, pre-processing, and then EDA task, that is your exploratory data analysis, then your machine learning models, that is your training and running all these. This is actually it just showed up like there was a wrong ID which was kept, but here you can see the models were trained properly, and it pipeline completed successfully, and everything was done over here. So here, if I click on this, so here for each model, again we can see the feature importance, and then this was what I was showing you, feature importance, then your CPU usage, disk size, memory allocated, and all these things like F1 score, precision, recall, accuracy. These are the statistics for your classification, like F1 score, precision, recall, accuracy, F1 score, and all these. If we go to the regression, for regression models, it is having other statistics. Like if I go to your linear regression, so here we can see these are the like R2 score, R square score, RMSE, MAP, MAE, MAPE. All these values are being logged over here. We can also see like the different, like what are the features, what are the test samples, train samples, how many have been used, random state has been kept same, so that we produce the same data for same data set, and then output that your model is ready. Another thing which I can show you is I have a scheduler. So apart from this, like we can run it one time, but we can also like schedule it to run every 5 minutes. So here I have like a scheduler.py. Here in this, I have a logic. So here I'm providing it the option whether it wants it as a single execution. So if you pass minus minus single, it will just run it once. Else, basically, it will schedule it. So here I'm scheduling it to run every 5 minutes. All this is already running. Apart from this, I have this API server. Basically, these are the APIs which I have exposed over here. So setup routes. So here I can see some of the APIs which I've exposed. I have this postman over here. I can show you from here. So the first thing is health. So you can see that all the 6 model status, it is showing to be healthy. The number of models which are being loaded, it is showing you. Then if I click on models, it will show me the details of each and every model over here. So you can see like linear regression, where is the trained model? It has been saved in this directory. So similarly, logistic regression and all these models which are there. So these are the trained models file. If I scroll down, 1 second. So then I have model name and info. So I can select a particular model and I can say models and then info. So it will give me so this is this, then models, model name, and then info. Models, model name, and info. Model, okay. Here I can change the API to models as per the REST standard. So here I can see it is giving me for a specific model, the detail, that is a type regression, and where is your trained model file and all this. So then if I go to, then this is the one which can actually predict. So you pass in the data, and for that data, it is even the UI. We are using these to predict the regression and classification. So here I can go to the Postman collection. So here, if I pass in the data, like my data set, like area, bedroom, bathroom, and I say predict classification, it will it is giving me the predictions. Like this is for logistic regression, random forest, and XGBoost. What are the values for it? And if I want regression, I can specify regression, and it will give me the values for my regression. So here it is giving me the confidence formatted price, predicted price, and price range, and all this value. The same thing which we were showing in the UI. So like this, I can use it to predict any kind of a. I also have an API which can help me predict only for a particular model if I want. So this is doing for all the 6 models, predict classification for 3 another. And if I want it only for a particular model, I can say predict, and I can say instead of this, I can say XGBoost regression. So then it will basically predict only for that particular model. So here you can see now it is only giving me for this is my input data and this is the model value for it. Apart from this, I have a route for visualizations. So I can access any chart whichever I want. So if I click on visualizations, this is a post method. I'll go over there. So this is the visualizations. If I make a get request, it will show me these visualizations, like whatever graphs and all I have, model evaluation, correlation matrix, and whatever graphs I have, and for each of the model, and then I can access these from there. Even particular one, like I can access using visualization. So for example, I'll pick up this one. And I can get it like for that particular one. These charts, these are being used even in the UI to show all the status. So then we have another one, which is your monitoring. So here it is best underscore models. It will show you like whatever are the best models as per the after the training. And here I have another one, monitoring status, which will show me basically the status of your monitoring. This is a work in progress. I'm trying to add some monitoring to these. So like monitoring trigger, it will trigger your monitoring. And then best models, which will show you the best models which have been trained. So this was the thing which I have. Then you have a run pipeline with tuning. So here what you can do is like you can run this housing pipeline, and if we are setting the enable hyperparameter tuning to true, I'll just take you over there. Run complete pipeline. So here you can see enable hyperparameter tuning is there. This will decide whether it has to tune all these models. And if it is true, I'm just going to run training with MLFLOW. So if it is true, what is it doing? It is trained with hyperparameter tuning. And when it is trained with hyperparameter tuning, basically we are passing the range of parameters for our models. And based on which it is calculating the best model. So instead of just hard coding the value for these, I'm setting it like a range. So Y target minimum is like 0.3 F. 1 minute. So here CV folds the number of iterations, and also if I go down, get best tuning results is equal to tuning results dot get best model. So after basically it has tuned, it will run it. It will find out with the best parameters. It is comparing based on your best score. Best score would be like for classification, it is accuracy and all it is considering, and for regression, it is considering RMSE and R square values. One second. Here in the MLFlow, we are logging parameters, artifacts, everything. Here it is choosing whether it is regression or classification. If it is regression, tune hyperparameters. This is the one. So if we click on this one, so here you can see like parameter grid. So this is basically which is dynamic over here. So here these are the ones. So for example, you can see for random forest, we are passing the grid. So based for different like max depth, we have set it as 10, 20, 30. For minimum split 2, 5, 10. For minimum sample leaf, for maximum features and estimators. So it will run in the combination for all these for each and every model, and then it will tune it based on this. So whichever is the best, it will save it as a best tuned model. So we can trigger a pipeline flow which will do the tuning and it will figure out the best model based on the data if it is needed. So here I can show you the artifacts. When you go to models, you can see there are two folders which are being created. One is your trained model right now, which has all of this. And if I'll run this with hyperparameter tuning enabled, it will also create a tuned model, which will have the latest, and also it will update the trained models over here. So again, it has a config file, which is saving which is the best classification model out there. Since the applications are already running, I need not restart them. So this is about it. And this is the complete documentation, which I have created, which has all the method UI screenshots and the code screenshots and snippets and the explanation for what the code is doing. That is it from my side. Thank you.